So what would the equation be for a linear relation? Slope y-intercept. Yep, y plus a. Now when we're talking about table of value, what do you notice in a table of value? Like remember, with table of value I'm talking about first difference, second difference, ratio, all of these, right? So when I have a table of value, how do I know that this is a linear function? What do I do? The first difference is going to end up being constant, right? So if you're doing a table of value and then you end up with a first difference of constant first difference, so all the numbers are the same, then you know it's a linear function, right? So the table of value, your first difference is constant. Okay? How would a graph of a linear function look like? It's a straight line. So it could be increasing, it could be decreasing, but the important is that it's a straight line. It could be vertical, it could be horizontal. Now, if I want to compare the linear relation to a quadratic relation, can you just give me the standard form of the quadratic function? So what's the standard form? Good. So this is the standard form. Remember that there is two other forms? That's right. But we're going to use the standard form because this is the one that is expanded. Okay? Now, in a table of value, right, what would be constant in a table of value for quadratic? The second difference. So when you see that the second difference is constant, that means we have a quadratic function. Great. And what do we call the graph? A parabola, right? And it can open. Excellent. Now the new function that we're learning is called the exponential function, right? So the exponential function has this kind of equation. So there's different format for the equation. Similar to the quadratic, similar to the linear, there's different formats that we have, right? So the one that I'm going to introduce right now, it doesn't have to be the one that we're going to be using the whole time. As I said, I'm going to be showing you different format of it, okay? And then we're going to talk more about it when it comes to that point. But for now, we're just going to use the basic one, which is y equals b as your base, and your exponent is going to be the one that is variable, okay? Which we're not used to. We're used to having the exponent as a number and the base as the variable, okay? In the exponential, it's the other way around. Your base is a constant. We've seen it before, right? If you remember the previous question, the base was 2. So the base was constant, and then the exponent was the variable. And this is what we're going to see. This is how we're going to be able to identify the exponential function. Okay? That the exponent is going to be a variable. In the table of value, what was constant? The ratio, that's right. And remember, with the ratio, you do y2 divided by y1. And how would the graph look like?
No. First, the numbers they're going to increase slowly, but you're going to have a very high increase.
That's right. And so it's going to be flat on one side, and then either increasing fast on the other side or decreasing fast, okay, depending on what kind of function I have. So I can have something that looks like this. This is basically what we just have seen. Right? This has to be straight. Or if it's decreasing, it's going to be like this. Okay? So it could be increasing or decreasing. So we're going to have these shapes. Okay? So this is, right now we compared all three functions that we have talked about before or we have seen in our previous course. Okay? Alright. Now, how do you recognize them? You have to use this table to be able to recognize. So examine each equation and determine the type of relation it represents. So is it linear, is it quadratic, or is it exponential?
Linear.
It's not linear,
And because the exponent is the variable. You see that your base is 5 and your exponent is the variable, right? So this is exponential. How about the second one? Quadratic, degree 2. How about the next one? Degree?
0.
Nope.
1.
Okay, so what you're going to do for the next one for me, you're going to fill out these tables. I'm going to just help you with the first couple here. And this is 1/2 to the power of x, so we're going to just do a couple. But then you're going to do the rest, okay? So if I'm looking at this, and I have, so my base is 1/2, and it's to the power of -2. I don't want to use the calculator. I want to use my head. So 1/2 to the power of -2. How can I write that as a positive exponent? What would it be?
2 over 1 negative positive 2.
So 2 over 1 to the power of 2, right?
Yeah.
And what is 2 over 1 to the power of 2?
2 times 2 is 4, and 2 times 1 is 1. 2. 0. 1.
It's 2 to the power of 2, so that's
That's
4.
4.
1 to the power of 2 is 1. So the answer is 4. 1 to the power of 2 is 1. 1 times itself is 1. Right? So, why did we make that exponent positive? How did we make it positive? We flip the base. So you take the base, you flip it. So instead of 1 over 2, it becomes 2 over 1. And you make your exponent positive. Right? So anytime you have a negative exponent, you're going to flip the base, make your exponent positive. Are we okay with that? Alright. So, if I have -1, 1/2 to the power of -1, what would that equal to? What would it be?
-2.
Y minus. What do I have to do with the base? Flip the base, it becomes what? 2 over 1 to the power of 1, so that's what? 2. How about 1/2 to the power of 0? What did we say? Anything to the power of 0 is?
1.
No, 1. Anything to the power of 0 is 1. That's what you guys must all try. What's 1/2 to the power of 1?
2. No. Just wait a second.
It's 1/2, right? is a half to the power of 1. Okay. How about 1/2 to the power of 2? It's 1 to the power of 2. So 1/4. Yep. Right? So you have 1/2 to the power of 2. 1 to the power of 2, that's 1. 2 to the power of 2, that's 4. We're doing power, not multiplication.
Oh.
Okay. Let's do the first ratio. What do I do for the first ratio? Division. So what do I do to divide? So 2 divided by 4 is? No? 2 divided by 4. 2. So if you have 2 chocolates and there's 4 people, how many would each get? You have 2 chocolates, 4 people. They get half. Right? 2 divided by 4 is a half. What's 1 divided by 2? Half. 1 chocolate bar, 2 people. What's half divided by what? You have a half a chocolate bar and 1 person. What? And guess what 1/4 divided by a half is? A half. There's no later. It's just the same thing. Right? 1/4 divided by half. You want me to show it to you algebraically? 1/4 divided by a half. Right? So I can change the division into multiplication. But to do so, what do I do with the second fraction?
Denominator change by denominator.
So it flips, right? So I change the division into multiplication. I flip the second fraction. Okay? Now, if I'm multiplying, that's going to be 2 times 1, which is 2. 4 times 1 is 4. What's 2 over 4? Reduce 2 over 4.
1 over 2.
So what do you notice about the ratio here? Yeah, and is it the same as the base? What's your base? 1. That's your base, right? So your ratio is the same. So it is exponential. First ratio. I already know it's going to be exponential. But I have to prove it, right? For it's constant. Right? I have to prove it. I already knew, because look at my equation. It's 1/2 to the power of x. My exponent is a variable. Right? I already know the answer. I just have to prove it using the ratio. So what I'm going to do right now is I'm going to do the other table. It should be a little easier. I don't want decimals, I want fractions. So if you get a negative exponent, and then for some reason it's going to give you decimals, you're going to have to prove it to me using fractions, okay? I'm going to stop this.